PE4332 pulse eddy current flaw detector operates through the insulation casing, which can be made of aluminum, stainless steel, or galvanized steel. Today we are going to test PE4332 under the most realistic conditions. We'll use a pipe consisting of 3 sections with different wall thicknesses. We cover the pipe with 100 mm thick insulation and install a casing over it. During the calibration, we specify the pipe diameter, the insulation thickness, presence, and the material of casing, as well as the pipe wall thickness for the section where calibration will be carried out. Such calibration, including specification of all the parameters of the tested object, should be carried out every time before starting taking measurements on the new object. Let's check whether the device can sense the 3 sections with different wall thicknesses and correctly measure the wall thickness along the entire pipe length. We do not start measuring from the very edge, since the measurement method has edge effects that can negatively affect the results. We notice a significant change on about 1/3 of pipe length near the first transverse weld. The change is not stepwise, but rather smooth. This is due to the fact that the sensor measures the average wall thickness in the space underneath the sensor. Near the second transverse weld, we see a thinning of the wall thickness down to 4 mm. The device detected 3 sections with different wall thicknesses. That corresponds to real situation, although it significantly smoothed out the areas of stepwise changes in thickness. This is the expected result, since the magnetized area of the pipe that affects the measurements at the current point is comparable and even slightly larger in size than the sensor. The purpose of the device is to detect large corrosion spots under a thick layer of insulation. Let's complicate the task and install a galvanized casing. We see that the casing magnetizes, which means that it will confuse readings of devices based on electromagnetic effects. In our case, the distortion resulted from the acoustic effect, which we can dampen using a special cap. When calibrating, do not forget to specify that the casing is made of galvanized steel. We see that the device can measure the pipe wall thickness under both insulation and casing, including tin casings. Test results. The PE4332 pulse eddy current flaw detector has measured the pipe wall thickness under 100 mm thick insulation with both aluminum and tin casings.